Till now, we have discussed about the atom's old view, in which all the estimations are being taken from the atom lying in the outside only. Now, after 1906, Rutherford was the first one that he tried to probe inside the atom to get the accurate picture of that. He has taken alpha particles and made them to fall on the photographic plate, and he got the impression of that on the photographic plate. He has conducted that in vacuum and observed a sharp image is formed. Now, in case if a thin foil of metal is placed between the emitted alpha particles and the photographic plate, a thin foil of metal is placed, then what has happened? The image has got diffused. So he concluded that this is due to the scattering of the alpha particles by the atoms of the foil, that is of metal. Now, in 1909, Giger and Marston, both are the students of Rutherford, they are also doing the practice in the same lab. They found out that a series of experiments have been led to the discovery of the atomic nucleus. So, whatever the Rutherford has concluded, that when the alpha particles are incident on a metal foil and this thing is taken inside a vacuum, so there is no other interference, and when the photographic plate is observed, there is not a sharp image, rather a diffusion is there, because the atoms particles present inside, they are scattering the alpha particle rays, and because of that, that photographic plate is formed. And Giger and Marsden in 1909, they performed a number of experiments on this fact, and they have found out the atomic nucleus. They discovered the atomic nucleus. Now, this is the experimental setup of Giger and Marsden for the alpha particle scattering. This is the alpha particles. This is alpha particle source is a radioactive element, and here high energy alpha particle beam was used by them, that was produced by radioactive material polonium. It falls on the gold foil. These are the atoms of the gold foil. And here we are having the scintillation counter. After deflection or after going through interaction with the atoms of the gold foil, the particles are being collected and counted by the scintillation counter. Whole of this arrangement is kept inside the vacuum so that there should not be any interaction between the alpha particles with the air molecules. So, a high energy beam of alpha particles, they are produced by polonium. This is the radioactive material that is being used, and they are made to fall on the gold foil. Whole arrangement is kept in vacuum so that there is no collision of alpha particles with the air molecules. There is a scintillation counter that is going to pick and take the counting of the scattered alpha particles that are coming in the various directions. Now, when the outcome of the scintillation counter is being observed, it have been found out that the gold foil is making the alpha particles to scatter, but most of the alpha particles are scattered through angles of 1 degree or less. It means deflection here is very less in maximum number of the particles, but a small number around 1 in 10,000, they are getting scattered through 90-degree or even at 180-degree. So based on this deflection and the range of the angles up to which the deflection is being done, so this thing is successfully observed and explained by the Rutherford, that is in the year 1911. And when he was explaining this deflection and the large angle scattering, he also proposed a very important thing, that is the structure of atom. In 911, Rutherford explained the scattering experiment of alpha particles by the gold foil. This is a nucleus of a single atom, and these are the few incident beam of alpha particles are considered, and the deflection can be seen from the diagram of the scattering of alpha particles in the Rutherford model. So, while looking at the diagram, we can see that most of them get undeflected. So this is the first conclusion that he has found out. Most of the alpha particles passed through straight way through the gold foil without being affected anyway. This suggests that Rutherford concluded that atom is mostly hollow inside. Second thing is this: the alpha particles, they are positively charged, and when they are scattered through very small angle, it suggests that they are getting scattered from positive charge only, as alpha particles are positively charged. Hence, scattering of the alpha particle through small angle indicate that portion of the atom responsible for scattering must have positive charge. From here, it is concluded that whole of the positive charge of the atom must be concentrated at one very small place, at one place only. So this conclusion is in contradiction with the atomic model that was given by the Thomson. According to him, the mass is uniformly distributed of the within the atom. So this is not so, because one thing is it is hollow inside, and second thing is whole of the positive charge, rather than uniformly distributed, it is concentrated within a small region according to Rutherford. So this is the third point of conclusion of Rutherford's alpha scattering experiment. It has been founded that a few alpha particles experiences a high deflection, though they are highly energetic and positively charged alpha particles. With even such high values, a strong repulsive force is being suffered, and because of that the large angle scattering taking place. So this thing happens only when the alpha particles are very close to the positive charge, and it means positive charge in the atom, because this deflection is of few particles only, alpha particles only. So from here it is being confirmed that this positive charge in the atom is concentrated in a very small region, an extremely small space at the center of the atom, and that is called the nucleus. The fourth conclusion of Rutherford's alpha scattering experiment is that the nucleus is surrounded by cloud of electrons whose total negative charge is equal to the positive charge on the nucleus, so that atom as a whole is electrically neutral. The fifth point is very important conclusion of the alpha particle scattering. It confirms the validity of Coulomb's law. Here, Rutherford has assumed that alpha particle is experiencing the repulsive force because of the nucleus that is positively charged according to the Coulomb's law. So, according to that, the force exerted on alpha particle due to the nucleus is inversely proportional to the square of distance between alpha particle and nucleus, that is Coulomb's law. On the basis of this Coulomb's law, Rutherford also calculated the relationship between the number of alpha particles scattered and theta, the angle of scattering. He found that the number of particles that are alpha particles is inversely proportional to the fourth power of the sine of half of the angle. So this relation is taken by the Giger and Marsden, and they also performed a number of experiments based on this formula. Now, the relation that have been found by the Coulomb's law on applying it on the force of repulsion between the alpha particles and the nucleus. This relation is being confirmed by Giger and Marsden by doing number of experiments on it, and they found out this type of graph. This type, the nature of graph is same as the theoretical prediction of Coulomb's law. and this graph goes well in accordance with the experimental data that have been produced by the Giger and Marsden. So this confirms that scattering of alpha particle by the nucleus is in accordance with the Coulomb's law, and Coulomb's law is valid for the atomic distances also. So this is one of the very important conclusion. Rutherford has not limited to only the gold foil metal. Rather, he acquired the knowledge about the positive charge in the atoms of different metals. He made to fall alpha particles on gold, silver, platinum. Means he was working on different metals, and what he has concluded that the counted number of particles scattered in definite directions, and found that this number was different for different metals. Further, two more important conclusions are drawn from Rutherford's experiment when he was doing it on different metals. Rutherford analyzed that the number of alpha particles that are scattered in a definite range of a metal foil is directly proportional to the square of magnitude of the positive charge of the nucleus. It means the number of particles that are scattered will be directly proportional to how much is the positive charge on the nucleus. And second very important thing, the Chadwick, another scientist in 1920, on the basis of this concept only, he has determined the positive charge in the nuclei of different metals, and he found out that this positive charge on the nucleus of metals is Ze, where E is the charge on the electron and Z is the constant of any metal, that is its atomic number. So we conclude that the number of particles that are scattered will be giving us the idea about the nuclei, and different metals have different charge on the positive charge on the nucleus.